know, it's right.
Kids coming up have just amazing projects. As we wandered around, we're like, oh my gosh, what is, we don't even understand what some of these things are. And we stumbled, or actually met Conor Maddry, and we were instantly amazed by what Conor had built. And so Conor won the Smart America Award at the Intel International Science and Engineering Fair, and afterwards we reached out to Conor and said, would he come and give us a little talk about what he built and why he built it and such. So I'd like to introduce Conor.
So I'll talk a little bit about my project first. It is a pneumatic electromyographic exoskeleton, and that consists of three main sections. There is the exoskeleton itself, which is made of aluminum and plastic. There's the pneumatics, which just move the exoskeleton and add rotational torque to all the joints. And then there's the electromyographic section of the exoskeleton, which takes the signals from my muscles and then converts that into telling the pneumatics when to move. So the electromyographic portion of the exoskeleton was by far the hardest. This takes small electrical pulses that, well, every time you flex, they're the small electrical pulses that go down your muscles to trigger your skeletal muscles for you to move. And I put electrodes on all of my muscles, and every time that I flex, it picks up that signal and then puts it through an amplifier, then a low-pass filter to get rid of the noise, and then a voltage divider, since most of the signal is negative, so the microcontroller can read it. And this is the signal that comes out of that circuit board. The circuit board, I originally started with one that I got off the internet that was much larger. It was about 4 times larger than the one that I created, and it didn't preserve the waveform. It was just an on-off signal versus actually having the wave, so you couldn't detect things like trapping, which is when your muscles get tired. So this is the signal. It goes into the microcontroller, which is an Arduino Uno, and it takes the center line of that signal and then sets a threshold above and below. And then if the signal goes above or below either one of the thresholds, then it knows you're flexing and it turns on the corresponding valve, which is on the back. This is the upper body of the exoskeleton. But on the top, there are the valves, which is just in a manifold, and then all of those connect to the various pneumatics around the body. There are 14 of these systems in total. So basically, you get the signal from your muscles, it amplifies it, it reads the signal in the computer, and then sends it to a valve, which then sends air pressure to the corresponding pneumatic, which then adds rotational torque to your joints. So the best analogy would be if you're picking up something and then someone grabs onto your arm and then moves up with you. So it just moves with you to increase your strength. And this is the suit all together. It can be used in a variety of applications. It can be used in an industrial setting for lifting up heavy objects or moving around supplies. It can be used in a military setting for moving around large objects and walking long distances. Or it could be used in a rehabilitation setting, because the power in the suit is adjustable from 0 to 120 psi, which is the amount of pressure that goes into all of the pneumatics. So you could pull the pressure down and then use it to suggest movements for recovery after surgery or something like that. Or you could use it as resistive as weights. And how I started building this was, it all started last year's science fair. I was struggling to find an idea, and I was watching Iron Man one night. So I decided to try to make some sort of exoskeleton that could increase your strength. So I came up with a small exoskeletal elbow brace, which wasn't very effective, but it did still prove that I could make an exoskeleton that actually increased your strength somewhat. So I went to my regional science fair last year, and I got to go to the International Science Fair along with an award from the Defense Agency. And the International Science Fair was a great experience. I got to see all of the other scientists there who were just as excited about science as I was, and had been, like, years of work had been just all put together and everyone could collaborate, and it really inspires you to continue working on your project so you can actually showcase it in front of all these people. And when I got back, I got to present to the Missile Defense Agency, which was another great experience. I got to meet the executive director along with the chief of staff. And they sent me over to an internship at Johns Hopkins Applied Physics Laboratory. And all of these awards and going to the science fair and meeting all these people really inspires kids like me to continue working on their projects and really try to strive and make it so that you can actually showcase it and be proud of it in front of all these people.
Great.